planet Earth. Billions of years in the making. Beautiful, precious and unique. Our home. How we interact with our landscape has shaped our history and provided the basis for everything we know. For the last 175 years, one evolving organisation has led the way in discovering and interpreting what lies beneath us. Its quiet influence has supported social, economic and scientific revolution, and it still does. This is the story of how that's happened. How an idea in the minds of a few dedicated visionaries has become such a vital part of the scientific community, respected and admired all over the world today.
It's very important work that we do here.
Huge value to people all around the world.
The organisation has come up with some fantastic ideas.
A real centre of scientific excellence.
We're able to build long-term relationships.
The BGS name is known throughout the world.
People do look to us.
Getting different science areas together.
Prestigious to be a part of it.
It's an organisation that's always moving forward.
I find it's getting better and better.
This is the story of the British Geological Survey. Hi, my name's Kathy Scheib. I'm a geochemist and I work here at the British Geological Survey. And often people ask me one question: what is the BGS? At the BGS, the behaviour of volcanoes, earthquakes, groundwater, glaciers are all analysed by some of the finest minds in geoscience, looking for solutions to help us all. At the BGS, we can solve a 1,000-year-old Viking murder mystery, or show a view of the Thames no one's ever seen before using unique technologies we've developed ourselves. At the BGS, we're forging partnerships across the country and across the world to tackle the biggest issues facing us all. And at the BGS, we're doing all this and much more while adding to the sum total of 175 years of accumulated knowledge about everything beneath us, around us, and above us. At the BGS, we're touching and improving everyone's future. So, how did we get here? How did it all begin back in 1835? Well, this was a time of massive social and economic change. The Poor Laws were reformed, the railways were expanding, industry needed more coal and iron. So was the formation of a geological survey one result? No, it was actually due to this, to sugar. This is Henry de la Beach, sugar plantation owner and amateur geologist. He'd been captivated by the new science and poured most of his money and energy into it, inspired by the findings of James Hutton at Siccar Point in Scotland in the late 18th century, and then by William Smith's revolutionary geological map of 1815. But de la Beach also had a problem. Sugar was plummeting in value, so he needed a new way to make money. His solution? Combine business with pleasure.
You have de la Beach, under his own initiative, approaching the Board of Ordnance for some funding to help him map the geology of Devonshire. And he was prepared to do this work for 2 years at a loss, essentially, so that he could then move on to the next stage, which was to suggest that perhaps the Board of Ordnance would like to survey another area. The Treasury agreed, and as a result, the Geological Survey was born on the 11th of July 1835. And de la Beach's genius was in actually maintaining the Geological Survey and keeping it going, in turning it into a permanent organisation.
With simple tools, the geologists of the BGS set about revolutionising the way we think about the land. As the number of people expanded, so did the work.
1866 to 1871 was the Royal Commission on Coal.
Well, this is the very basic geologist field kit.
1872 saw the introduction of hydrogeology into the work of the survey.
This is very obviously a hammer used for hitting things and getting rock samples. It's a moderately heavy one.
1893 saw the creation of the Imperial Institute.
Compass, so you know where you are, where you're going.
1914 to 1980 saw the wartime assessment of the mineral resources of the UK.
The obligatory geological survey map case.
In a way, one thing leads to another. Underground water is polluted by landfill sites. So then you have to understand what happens with the landfill sites.
And finally, you need a good pair of hobnail boots.
And the legwork has increasingly taken BGS staff further afield. These pictures are from expeditions to Egypt, Central Africa and South America in the 1970s, as the BGS has adapted to a changing world and exported its expertise to all corners of the globe. The BGS has always known how to change, and even though Della Beach wouldn't recognise much of the science now, and even less of the equipment, he would recognise our ethos, looking to the next challenge and serving all our needs. So, here are just a few examples of where we are now and where we're going.
It's important for an organisation like the British Geological Survey to provide reports, statistics, web pages for the general use of government, for industry and also for general members of the public. On the mineralsuk.com website, all of that information is available.
The main aim is to try and reduce risk. We need to make sure people understand risk, understand the volcanoes and understand what they're capable of to reduce the impacts of future volcanic eruptions.
Water is so important to life that we ignore potential problems that are peril, and therefore we need to have a very good handle on the availability of water underground.
Because of the investment we've made in our own technology, enables us to export that technology to developing countries, to support colleagues in institutes in places, for example, in the Far East, in Africa and in the Americas.
The data we provide and the maps and publications we put together, they actually have a direct input to our lives.
Things I've learned from GBase I've actually applied, and I'm going to do that in my dissertation.
I'm going to do a Masters in Geochemistry as a result of doing this project.
You can see how the layers interact with each other, which the human brain can't process when looking at a 2D geological map. 3D enables people who don't understand geology to understand geology.
The scale of quarrying as an industry and the industrial heritage behind that, no one else is really investigating that and looking into that as much as the Building Stone team at BGS is doing.
We've taken a machine called a terrestrial LiDAR and we've scanned the foreland and the margin of the glacier, and we're going to be going back year on year to see how both of those change.
We're seeking to develop this cutting-edge technology so that other people can benefit, if you like, from technology that BGS has developed.
The kind of work that we do provides information on expected ground vibrations, and that allows planners and engineers to construct buildings so that they can best withstand the type of earthquakes that might occur in those places.
You can communicate the enthusiasm to school kids, the public, and it just adds a dimension of spreading the sort of fun of science so much more, and I love that side of it.
It's very important for us to build up our knowledge of the seabed. It's very important that we do that by collaborating with other marine organisations and industry to make sure that we derive maximum benefit from the kind of environmental data that we're able to collect.
And that really is just a few examples of the work that we do. We haven't even touched on all the time we spend with schools, colleges and universities. Time spent introducing children as young as 8 or 9 to some of the fundamentals of the world they live in, or time spent organising events and schemes to encourage the earth scientists of the future with their studies. So, in the end, we come back to that question, what is the BGS? Well, it's clear that to everyone, it means something different.
We provide a good environment for people to work.
I like the multidisciplinary aspect of BGS.
Fantastic resources in terms of laboratory and data sets.
Blue sky science.
Useful, practical research. It contributes information that people need.
A benchmark in terms of information and geological information and maps, advice, guidance.
Something that will hopefully go on for another 175 years.
Mitigating the impacts of future disasters.
We might be looking at the geology of the Moon or Mars.
Volcanoes, earthquakes, climate change, carbon capture.
I'm sure there'll be many things for BGS to be working on long into the future.